Welcome to Get a Clue number 7, selected problems from the Algebra 2 second 6 weeks final. The first one we'll look at is problem 4, solving this system of equations. I allowed you to solve this system however you wanted, and most of you got this one correct, fortunately. But I really would like you to be able to solve this problem using elimination as instructed. This system is not ideally situated for solving by elimination, where we can just add or subtract equations from each other to eliminate a variable. But if we multiply the top equation by 5 and the bottom equation by 7, let's see what happens. Here are the transformed equations lined up, one above another. Adding the two transformed equations together, the 35y minus 35y cancel, and we have 61x equals 244. Now we divide both sides of the equation by 61. 61 over 61 cancel on the left side. We bring down our solution for x equals 4. We take that 4 and put it into one of our original equations so we can solve for y. So using the first equation, it becomes 8 times 4 plus 7y equals 18. This simplifies to 32 plus 7y equals 18. Subtract 32 from both sides of the equation. Cancel 32 minus 32 on the left side of the equation. Bring down what's left, 7y equals negative 14. Divide both sides of the equation by 7. 7 over 7 cancel on the left side. This simplifies to y equals negative 2. We check our answers in the graphing calculator by storing 4 for x and negative 2 for y and entering both equations. And we see that x equals 4 and y equals negative 2 is the solution to this system. So we box in our answers here and choose answer C, 4, negative 2. Let's look at problem 6, one of the toughest on the test. We can make this problem a lot easier if we remember that vertices of a shape will be caused by intersecting lines, so we really don't have to worry about shading above or below these inequalities. We just need to see where the boundary lines intersect and check the coordinates that match those intersection points. In y1, we enter the boundary line for the first inequality by subtracting x from negative 9. For the second inequality, we can just enter the boundary line as y equals x minus 7. We can enter into y2. And for the third, we have to subtract x and divide by 2 to solve for y to enter this. Press zoom 6 to see a standard window. In addition to seeing 3 lines, it looks like we see 2 intersection points. I would like to introduce a test-taking technique here. Go to Stat, then press Enter. Enter the points for choice A here, the x-coordinates in the L1 column and the y-coordinates in the L2 column. Go to y equals view. We see our equations there as we left them. We arrow up to plot 1 and activate it by pressing Enter. This is what it looks like highlighted. There will also be a blinking here as well. Press Zoom. Then 9 for zoom standard, zoom stat. We see that 2 points line up at the vertices, but we need all 3 points. So we cross off A as incorrect. Now we can enter the points for choice B. We press zoom 9 again and don't even see the 3 lines, we see only 2 of them, so we cross off choice B also. We try choice C by entering the points here in Stat Edit. Then we see the points graphed by pressing zoom 9. We see all the lines just fine, but none of the points are at the vertices, so we cross off choice C as well. We enter the points for choice D, which better be correct since A, B, and C did not work. Then we press zoom 9 and we see that each point is right on each vertex, and we circle D as the correct answer. Number 7 is the leather and canvas wallet problem, a pretty tough one in my opinion. The first thing to notice is that this one, choice D, has greater than. It's only less than or equal to that will work, since 44 yards of leather and 40 yards of canvas are the upper limits of production possibilities. So we cross off choice D. For the leather wallets, they need 4 yards of leather and 3 of canvas, and here's where they match, choice A. And the canvas wallets match here. So choice A is the one that matches everything. Be sure to check B and C as well. Let's look at problem 14, solving by factoring. And those who picked D got it wrong, and I haven't figured out why so many students missed this one. The first thing I thought of is that students didn't know that they needed to solve one side of the equation for 0 first. We can most easily do this by moving the 40 on the right side to the left side of the equation. It becomes x squared plus 3x minus 40 equals 0. And then we put them in the box here, x squared in the upper left and negative 40 in the lower right. And then we list the factors of negative 40 and their sums next to them. Here are the factors of negative 40 that match, or the factors that match the sum of 3. So we write in the factors on the top and side, then multiply them out. And here, combining like terms, we have 3x, just like our original trinomial to factor. And here's the equation in factored form. And are the answers negative 5 and 8 like in choice B? You have to be especially careful when solving by factoring. The test writer is setting you up with this answer choice. You break the two factors into two equations. Solving for each equation, you have x equals 5 and x equals negative 8, which is answer C. Be sure to do this problem at least one other way before you accept the answer. Graphing is a great way to go. You put the equation in Y1, then press graph or even zoom 6 to assure a standard window, and we see that our solutions here at x equals negative 8 and x equals 5. The last one, problem 21, was a challenge in that it asks for number answers and is not a multiple choice situation. We're going to look at doing this one using matrices on the graphing calculator. Here's the system written out larger on the right. To solve using matrices, we need both equations in standard form. We need to move this 3n on the right side over to the left side of the bottom equation, where it becomes m minus 3n equals 8. We take a good look at the two equations we're using to make sure they're correctly lined up, and they are lined up. The m's on the left side, then the n's, and finally the constants on the right side of each equation. Now we can go to enter the equations in the calculator. We press second, matrix, then arrow twice to the right to the edit menu. We enter a 2 by 3 matrix, then all the numbers in their correct places. Where we see only the variable like m or n, we just enter 1 since m means just one m. Now we clear the screen by pressing second, quit. We now go to RREF, or reduced row echelon form, by pressing second, matrix, then arrow once to the right to the math submenu, then down to choice B, RREF. Press enter. Enter matrix A by pressing second, matrix, then enter. Close parentheses, press enter. On the right side of the reduced row echelon form, we have these numbers. The number on top, 42.5, is the answer for M, $42.50, and the one on the bottom, 11.5 or $11.50, is the answer for N. We write our answers here and finally check them by substituting these numbers back in for M and N in the original equations. This has been Get a Clue number 7, selected problems from the Algebra 2 second 6 weeks final. Thanks for viewing.